Hi, this is the solution for the question 1 of homework 5 from Hw5. And firstly, we look at the questions first. It tells us the PDF function about x and y and the relation between z and x and y. It wants us to find the PDF function about z first. And first, it is a convolution method. It is easy that we directly calculate this taking use of this expression. And here we know that we use the value it provided the function provided by the question, and we get the result is like this. And we notice that this result equal to 1 only when alpha is greater than 1 and less than and smaller than 2, and this value equal to 1, and in the else situation is equal to 0. So we directly replace the integral up and lower bound to the 1 and 2. And for this part it is similarly it is equal to 1 only when the alpha is smaller than z but greater than z minus 1. So we combine this bound this range and this range together. We can easily get that when z is smaller than 1 or z greater than 3, there are no overlapping, so the result is 0. And here is the two different situations. The upper bound and lower bound is different. We calculate the smaller value of these two overlapping, and to the upper bound of this overlapping, we can get the two different situations and get the result. And for the second method, it told us to use the geometric method. It is easy that we can draw the figure like this, and we notice that the area 1 is that if we draw the line that z equal to x plus y, we know that the probability function is calculated by the area, by the downside about area of the downside of these lines. And for the PDF function, for the probability of x, we can easily know that only when x is between 1 and 2, this area is equal to 1 and other area equal to 0. And for y, only when y is between 1 and 0, this area 3 is equal to 1, and in the other area it's equal to 0. So combined x and y together, and they are overlapping. They're overlap only in their overlapping area. The x and y can both take the value. The PDF function of x, y in this function can both take the value of 1, and in other area they cannot take the value of 1 together. So if we want to calculate the probability function about z, we need to calculate the overlapping between the downside of this line and the overlapping with this area. So it is easy that when this line z moved, when z is smaller than 1, the probability equal to 0, and when z is greater than 1, greater than 3, it can cover all this shade area. So the probability of z here equal to 1. So their PDF function also gets by making some differentiate And here is another special situation is that when this z line is moving between here to here, when z is greater than 1 but smaller than 2, and we can know that the overlapping area is represented by this small triangle, so we just calculate this small triangle area. The value is that we easily know that the length is z minus 1, so the area of this smaller triangle is like this. It is z minus 1 times 2 divided by 2. So easily get a PDF function about z. It is this, and when this line move to here, when the z is greater than 2 but smaller than 3, we need to calculate this area, and this area can be calculated by using 1 minus this small triangle, also minus this small triangle, and this small triangle, its length is equal to 3 minus z. So the area of this small triangle is equal to 3 minus z times 2 and divided by 2. And here it is. It is the probability of z in this situation, and we make differentiate, we get the probability, get the PDF about z. And here is in conclusion, here is the PDF of z.